Hello, today we're going to talk about the trigonometric ratios. So, whenever you have right triangles, we are going to use the trig ratios in order to solve for missing angle measures or side lengths. So, there are going to be three sides that we are going to focus on when we're looking at trig ratios. The first side that we're going to focus on is going to be the opposite side. So, for our opposite side, you have to understand that we are going to be focusing on the angle that is across from a given angle. So that means that the side that is opposite of a given angle, it does not touch or help form the angle. All right. The next side that we are going to focus on is the adjacent side. So the word adjacent means to be right beside to. Okay, so the adjacent side means beside. So it is the angle that is basically next to or touching a given angle. Okay, and you have to understand that the adjacent side does help form the angle that is given. All right, the last side is the one that we are most familiar with. We are most familiar with the hypotenuse. So remember, your hypotenuse is going to be the side that is across from the right angle. Your hypotenuse is going to be the same no matter what. Okay? So it will not change no matter what angle you are focusing on. So for instance, let's say that we have this triangle on the left-hand side here. One thing that you should understand is that whenever you have angle measures, we have capital letters. So angles are capital, sides are lowercase. Whenever we write them as letters. And if you notice, if we're looking at angle A, the side that is across from angle A is the name lowercase a. If we are looking at angle B, the side that is across from angle B is labeled as lowercase b. And if we are looking at angle C here, the side that is across from angle C is what we call side C. So that is normally how we write. So if we are focusing on angle A here, angle A, if we talk about the sine of A, that means we have the opposite over the hypotenuse. Well, we already know that the hypotenuse is already across from the right angle, which means that it is C. So in regards to angle A, the side that is across from it is side A. So that sine is going to be A over the hypotenuse of C. If we look at cosine of A, that is the side that is next to A, which is going to be B, so that is going to be side B over the hypotenuse. And then tangent means that we have opposite over adjacent. So the opposite of side A is A, and we're going to have that over the adjacent, which is side B, so that's going to be A over B. All right, and last but not least, we have, if we look at angle B, we will end up having the opposite over the hypotenuse, which the opposite of B is going to be lowercase b over the hypotenuse, which is C. Cosine of B is going to end up being the adjacent of B, which is side A, over the hypotenuse, which is side C. And then last but not least, we're going to have tangent, which is your opposite over your adjacent. So that is going to be B over A. So as you can see here, the sine of one angle is equal to the cosine of another angle, okay? And it works vice versa. So the sine of B is going to be equal to the cosine of A as well. So I just wanted to make sure to point that out. So if you ever need help memorizing your trig ratios, all you have to think of is the following. So I tell my students I have sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, and tangent is opposite over adjacent. So I normally tell my students to write it out, all three of them, and then you're going to go down the side and you're going to put equal signs. And then on the right side, you're going to put down your division signs. So Sakatoa is how we remember that. All right, so let's look at some examples. So here we have a triangle with the different side lengths of 3, 4, and 5. And we have a 90-degree triangle, which lets us know that it's a right triangle. And we also have two angles. One angle is named theta. So this symbol right here is the Greek symbol theta, or the Greek letter theta. And this angle right here is the Greek letter phi. All right. So I want to find the tangent of phi. So if I'm going to be focused on phi here, I'm going to be focused on this angle here. And we know that tangent is opposite over adjacent. So when I say the opposite, that is going to be 3. And the adjacent is going to be 4. So I can see that my opposite over adjacent is going to be 3 over 4. The next one I want to find is the cosine of theta. Well, if I'm focusing on theta, I'm focusing on this angle here. And we already know that cosine is adjacent over hypotenuse. So adjacent means the side that is next to it. So that is going to be 3 over the hypotenuse, which is the side that is across from the 90-degree angle, which is 5. So when I have adjacent over hypotenuse, I get 3 over 5. Next, I'm going back to the Greek symbol phi, and I want to find the cosine of phi, which means I need to have the adjacent side, which is 4, divided by the hypotenuse, which is going to give me 4 over 5. Then if we go back to the angle theta, the sine of theta is the opposite, which is 4, over the hypotenuse, which is 5. So that is going to be 4/5. Looking back at the angle pi, or phi, we are going to have the sine of phi, which is going to be the opposite over the hypotenuse, which is 3 over 5. And then last but not least, we are going to focus on the angle theta. And we want to find the tangent, so that's going to be opposite, which is 4, over adjacent, which is 3. So that is going to be 4/3. So as you can see here, the rule still remains the same, that the sine of one angle is going to be equal to the cosine of another angle, meaning that sine of theta is going to be equal to the cosine of phi. Similarly, we know that the cosine of theta is going to be equal to the sine of phi. Okay, so that still holds true. All right, so let's talk about finding side lengths using trig. So if we find a side length using trig, we can say that we have a given angle and we have to determine what size that we have. So I have the angle 28, and based off the angle of 28, I'm trying to find the opposite side, and I am given the hypotenuse. So remember, keep in mind your trig ratios. So like I said, just write them SAW, SOH, CA, CAH, and TOA, which is TOA. So just make sure you keep that in mind at all times. Put your equal signs down the left, division signs down the right. All right. So now we should be able to set up our trig ratio. So here, because I know I have the opposite, I need to find the opposite and I'm given the hypotenuse, I'm going to use sine. So I'm going to have here that I have sine of 28 degrees is equal to x, which is my opposite, over hypotenuse is 52.4. So anytime you're going to use your calculator, you need to make sure your calculator is in degree mode. So you're going to press mode, and then you're going to go down and change it to degrees. Once it's in degree mode, you will see it flashing over the degree. And when you do that, you can go back to your main screen. So now you can also tell it's on degree, because if you look at the top near where the battery is, you can look to the left and you will see that it says degree up there. So in order to solve this equation, I need to multiply both sides by 52.4. So I'm going to have 52.4 times the sine of 28 degrees is equal to x. And if I put that in, I will end up getting approximately 24.6. And of course, that is going to be meters. That is going to be what x is. All right. So next, let's look at part B. Okay. So part B states that you have a right triangle. We can see that the angle that is given to us is 38. And we have sides A and B that we want to find out. So I'm going to write an equation for side A first, and then write an equation for side B. So if I look at side A, I have the angle 38. I have A, which is the hypotenuse, and then 43.2, which is going to be the side that is next to the angle, which is adjacent. So if we have adjacent and hypotenuse, that is cosine. So we're going to have the cosine of 38 is equal to the adjacent, which is 43.2, over the hypotenuse, which is A. So the first thing that I'm going to do is I'm going to multiply both sides by A. So I'm going to have A times the cosine of 38 is equal to 43.2. And then I'm going to divide both sides by cosine of 38. So I'm going to have A is equal to 43.2 divided by the cosine of 38. So when I type that in, I end up with A being approximately 54.8, and I know that is centimeters. All right, so that is what A is. So next we can find B. Okay, next we can find B. So anytime we find B, if we look at it, what's being given, if I look at the angle 38, I can see that B is the angle on the side across from it, so that's the opposite. And then I can use either A, which is the hypotenuse, or I could use the adjacent, which is the 43.2. And what I'm going to do here is I'm going to use the adjacent, because that is the exact number. Remember, we rounded A. So if I do it, I'm going to have the tangent of 38 is equal to the opposite, which is b, over the hypotenuse, which is 43.2, excuse me. So I know that in order to solve, I need to multiply both sides by 43.2. So here I'm going to have 43.2 times the tangent of 38 is equal to b. Once I do that, I can just literally type it into the calculator and get my answer. So when I do that, I will have 43.2 times the tangent of 38, and that will end up leaving me with 33.8 in 3 CV, and we know we're talking about centimeters. And that is what B is equal to. All right, so now let's talk about finding angles. So just like we can solve for side lengths, we can solve for angles as well. So make sure you understand that we have inverse operations of trig functions. So if we have sine, the way you get rid of sine is to take the sine inverse. Inverse means opposite. So we want to do the opposite of sine, which is called the inverse of sine. So now let's look at A. So if we look at A here, we see that our angle is angle theta. And our angle is here. And we are given the opposite and the adjacent. So we are given enough to find the tangent. So here we're going to have that the tangent of the angle theta is equal to the opposite, which is 2.1, excuse me, over the adjacent, which is 3.1. So the way we get rid of tangent is we have to take the tangent inverse. So if I take the tangent inverse of the left-hand side, I would just get theta. And then I need to take the tangent inverse of the right-hand side. So that's going to be the tangent inverse of 2.1 divided by 3.1. So in order to get to the tangent inverse, you press second tan, and you will see the tan with the little negative one, which means inverse. And then you just type 2.1 divided by 3.1. And that will end up giving you that your angle theta is approximately 34.1 degrees. We do not deal with radians in this course. We always deal with degrees. All right, so let's look at our last example, part B. So we have two angles that we need to find. We have theta and we have phi. So I'm going to use my trig ratios to find theta first. So when we look at theta, we have the opposite and then we have the hypotenuse. So that means that we're going to use sine. So here I'm going to have that the sine of theta is going to be equal to 5 over 8. And if I want to find the angle, I need to take the sine inverse of both sides. So I'm going to have that theta is equal to the sine inverse of 5 over 8, which means that theta is going to be approximately 38.7 degrees. Similarly, I can do the same thing for phi by looking at my given information. So for angle phi, I'm given the adjacent and the hypotenuse. So I'm going to do the cosine of phi is equal to 5 over 8, which means I need to take the cosine inverse. So phi is going to be equal to the cosine inverse of 5 over 8. And when I do the cosine inverse of 5 over 8, you will see that you get that phi is approximately 51.3 degrees. Now, another easy way that you could have done that instead of using the trig ratio is that you should remember the property that all angles on the inside of a triangle should add to give you 180. So if you knew that finding angle theta, if you knew that angle theta was 38.7 degrees, and you know that this is 90 degrees, then all you had to do was subtract those two angles from 180, and it would have given you the 51.3 for phi. So either or, you would have been fine using trig to find one angle and then subtracting the two angles from 180 to find the third angle. Or you can just use your trig ratios. So if you have any questions on the review of trig ratios, please ask for help, and I will see you all later. Have a great day.